Hello, everyone. Welcome to one more General Talks. I hope you, your friends, your loved ones, everyone is doing well during these challenging times. Today we have four amazing speakers. They all happen to be from Brazil. They are Google developers experts. And just before I welcome them to come here and share the amazing content they put together, I'd just like to let you know that we have a lot of events coming up. Saverio is going to share with you in the chat the links to our community if you're not already part of it, if you found this link from somewhere else. But we have, there are some known faces here in the chat. So glad to see it. So we have some initiatives coming up. We have data structure and algorithm study groups. We have a cloud certification we're going to study together. We also have throughout the month of March, International Women's Day initiatives. One of them is focused on actions on Google. And we have many mentors mentoring 3 different languages. And yeah, there's so much coming up. We're trying to consistently have at least one general talks every month. But ultimately, we're open to feedback. We're here for you. We're trying to experiment with different formats of events because some people tell me, I can only attend events before work, during lunchtime, after work. Please don't make it more than 1 hour. Please record things. So we hear you, we listen to you, and we're trying to give you the best we can. Our first speaker tonight is Álvaro Viebrantz. I'm going to invite him to come here live right now. He's going to introduce himself and all the amazing things he does. He is a big streamer. He's on Twitch. I get notifications all the time that he's streaming. So Álvaro and the other people I'm going to invite here today have been active in the community in the past years. And it is an honor to have them here with me tonight. So Álvaro, I'm going to get you on the stream right now. Hope you're ready. Hello.
Yes. Hey everyone. Yeah, so happy to be here. It's gonna be my first talk of the year, so yeah. Hope that everyone enjoy what I'm gonna bring here. And I mean, thanks for the invitation. It's a pleasure to be here collaborating.
It's our pleasure. Wow, we're so honored. First one of the year.
Yeah, we have to start.
Well, he has a GIF there. I pronounce GIF. For the GIF people, I'm GIF. So he has a GIF on his presentation, and I think I'll leave the stage to you, Álvaro. Do you need anything from me, or are you good to go?
No, I think it's all good. Just a fun fact: this GIF or GIF, it's like the reenact of the Lion King. If you noticed, I'm like lifting a Raspberry Pi to show how nerded I am with IoT. So yeah.
Oh God, you're the nerdy king. Okay, I'll leave you to present. Thank you very much.
Cool. Okay. Hello, everyone again. So my name is Álvaro. I'm from Brazil, like Amanda just said. I'm a Google developer expert for IoT. So if you want to talk about IoT in general, maker projects, and some hardware stuff, I'm here to help you. Recently, I changed my job. So now I'm working on a startup in San Francisco called Goliath. So we are building an IoT platform there. So it's really cool. But I have been working with IoT in production, like for real, in the past like 3 or 4 years. So it's really nice. So if you want to get some of my content, you can access my website. It's here on my slide. So aviebrantz.com. So you can see there, and you can just talk with me on any social network. I'll be happy to help. And today I'm bringing, it's kind of a new subject to me, but it's something that I'm working now on my new job. So I'm going to show a way for you guys to build a REST API. So something that we are kind of used to, like is the default way to build APIs nowadays. But I'm going to show how you can build REST APIs using gRPC and Go, so the Go language. So I hope you enjoy this this content here. So yeah, it's not passing my slides. Cool. So what is the current state of REST APIs? How we develop REST APIs nowadays? So usually we follow some conventions to say that our API is a REST API. So usually we try to use the most of the HTTP spec. So we use HTTP verbs to define methods. We try to leverage the HTTP response code. So 200 is like an OK. 404 is a not found. So we try to use those HTTP codes to say that we did something with our resources. Also, we use the URLs to define the resource location. So where are my books? Where is a book by ID, and etc. And also to define the serialization format, like if our content is in XML or JSON, we use content headers. And also we can use headers for other things, like there's even some APIs that use headers to do pagination. So yeah, all in all, REST APIs try to use the most of the HTTP spec to build APIs on it. So here I have a table with some examples here. So if you want to get a list of books, use like the HTTP method get, and the URL is like API/books. If you want to get a specific book, you get like /books/ID of the book, and I have other examples here for other types of methods. So yeah, in general, this is a REST API. And also, most of the time, our REST APIs are mostly just JSON over HTTP because, JSON is nice. It's like human readable. It's not that heavy. It's native to browsers and JavaScript. And also not just the browser, but JSON can be used everywhere. So if you're building a mobile app, like a web app, like you can always have access to a library or a native support to JSON. But JSON has some problems. Unfortunately, JSON is like loosely typed, so you don't have like you don't know which types you're gonna send or receive from your API. It's really like sometimes you just like try it out to use the API and see how is the response format. So you're never sure about how is the format that this API is going to return. And even the JSON is better than XML, still a bit more expensive to do the marshalling and unmarshalling, like converting your object JSON and converting a JSON to an object. So, again, also related, is not type safe. So usually when you have to do some validation, for example, if a field is a number or is a number inside of a string, you have to do the validation like manually on your end. There are some solutions to solve that, to like add more types to REST APIs. Like you can write like OpenAPI and Swagger documentations, or there's also like a JSON API spec. But still, like it's trying to solve a problem that I'm trying to show here from REST APIs. And if you're hearing some noise here, I have 5 cats, and now they're trying to make some noise here. So sorry for the noise. So yeah, what is Swagger specification? It's basically like some ways for you to type and document your APIs to make it nicer to like fix those problems of the loose typings of your API. So you basically can define which security model you use, which fields you return, which parameters your API supports. So basically, it's like a giant API that you can take a look and you improve your APIs by using that spec. And also a nice thing about Swagger is that you can have, like, for example, this nice UI from Swagger. It's called Swagger UI, that you can point your Swagger file to define your API documentations. And you can also try out your API. So you can see like which methods your API have, which parameters, and etc. So it's really cool to like use the ecosystem around Swagger. And also you can generate clients. So if you have the Swagger documentation, you can get that Swagger file and generate clients for Android, for iOS, for your browser, so you don't need to do the URL calls, like the HTTP calls manually. So yeah, unfortunately, the solution is to write more YAML or JSON to fix those problems with REST API. So I'm going to try to show a way that make that a bit easier. So I talked about gRPC APIs in the beginning, but what is a gRPC API? So gRPC is basically a RPC framework, a remote procedure call framework. So instead of like saying that I have URLs paths, URLs pointing to resources or HTTP methods, etc., I actually can call a method on a remote server. So that's basically the idea of a remote procedure call. So gRPC is a high-performance implementation of a RPC framework. It uses HTTP2 for transfer, so it's really efficient. You can also do bidirectional communication, so you can get a resource, but also the server can string responses for you. So imagine that you can listen in real time to a change for a resource on the server, so you can use that with gRPC. And also one nice thing about gRPC that is built on top of protocol buffers. So I'm going to talk more about protocol buffers and show some examples. But the nice thing about protocol buffer, that is, imagine that this is the equivalent to JSON and XML. So it's a marshalling or like a format that you can put your data on it. So it's basically a binary format. So it's faster and have a lower overhead than JSON and XML, for example. And it has like an IDL, like a language that you can define your messages and methods that you can call on your system. So the nice thing about that is that you have a single sort of source of truth. So you have your protocol buffer files defining your methods and objects, and you can generate your server code, your client code using that IDL. So it's you have a single source of truth of what is trafficking, what is being transferred on your API. And yeah, I'm going to show some more examples here. So when you have to build an API with gRPC, you basically have to follow some steps. So basically, you define your service, like which methods you're going to have and which messages are going to be transferred, like passed on those as parameters and responses. Then you generate this, the server and client stubs that you can use the protobuf compiler. And on the server, you have to implement that stub that is being generated and put your business logic. So maybe you put a method that is to list the books, and then you generate the server code, and then you go there and implement like, oh, I go to my SQL database and query my books there. So, but the transport part, you don't need to re-implement, like the gRPC communication stack, you don't need to re-implement. And then on the client side, you can just get that generated client and call the gRPC method directly. So it's pretty cool that you don't have to manually write the communication between the server and the client. So this is protocol buffer. So for example, imagine that I have this object here, which is a catalog entry. It has an ID, a slug, a name, image URL, and even like an enumeration here. And after you compile this with protobuf, this is, for example, the Go code that it generates. So it generates some structs from the Go lang, but I can also generate, do that same generation process for other languages. So I can generate things for JavaScript, for Java, for Objective-C, Swift, and other languages. And I have, again, a single source of truth of which objects are being transferred on my application. So that's the nice thing about using protocol buffers. And also, you can define services, which is the part that makes gRPC cool. So you can, for example, let's say that I'm defining a catalog server that I'm going to show later. That is the demo of this talk. So I have a catalog service that I can create a catalog entry. I can list my catalog entries here, and I have a search catalog filter. So you see, everything is typed. I know what are the inputs and outputs of my methods. And I can define like, okay, my search catalog filter have like a term that I can search for, like a string that I can search. I have an enumeration, which is the catalog type. It's a movie or a TV show. And I have the pagination parameters. So you see that it's explicit what is going to be the query parameters and the response parameters, which is much harder to do with the normal REST API. So when you compile that service file, you have like a server stub that you can fill in and implement your server. Like you can say, okay, how do I list my catalog items? So here, for example, I can put my code to connect to a database and etc. Like I said. Cool. By the way, folks, send your questions on the chat. Like I'll be happy to answer anything. And also, I mean, if I'm going too fast, let me know. But I hope you guys are getting all the things here, all the flow of this talk here. So yeah, also the nice thing, like I said, you can use the generated client. So here I generated a client for Go, but you can generate for other languages. But you see here, for example, I just set up the connection to the gRPC server, just the URL and etc., URL and port. But then I can like start a new client and just call the client. Like I'm calling a method inside of my code. So there's no, the thing is that all the abstraction to connect to the network and call like the remote server is all abstracted by the gRPC framework, which is cool. So here, for example, I'm creating the WandaVision catalog entry, which is a TV show, for example. But of course, everything has problems. So what are the problems of gRPC? The major downside, I would say, is that it's not directly supported in the browser. So to use gRPC, because it's HTTP2 based, most browsers are still HTTP 1.1. you have to use a proxy to convert a gRPC server to be used on a browser. So usually you can use projects like gRPC Web, Envoy Proxy, and there are other solutions that try to solve that. But again, like I said, that alone is like a big, really big issue, because I mean the web is the most democratic platform. So usually you want your product to be available on the web and want to access your APIs on the web. And also a lot of public-facing APIs, if you want to make your API available for others to use, most of those APIs follow the same conventions that I mentioned before. They are HTTP, JSON over HTTP. So you want to make your API available over that interface. So I'm going to show how you can do that. So yeah, so basically I'm going to show this project, which it's called gRPC Gateway, that basically get the best of both worlds and try to make the best tools available for you to use the nice things about REST APIs and the good things about gRPC, and you can build APIs using both. So what is gRPC Gateway? Basically, it's a group, or it's a list of like plugins, protocol buffers plugins, that also helps you to translate your gRPC services to be served over HTTP. So basically, you can convert some error codes from gRPC to become like HTTP response codes. Also some headers like gRPC metadata, it's how they call that word, gets converted to HTTP headers. So that library helps you to make that translation. And also add some annotations to your proto file. So for example, I have this method here to create a catalog entry. I can say that this catalog entry is on this URL and is a post HTTP method, and also accepts like a body that is going to be converted to this message here. And also another nice thing about gRPC Gateway, that it generates Swagger and OpenAPI definitions. So you also have your really well documented API. So that is really cool. But unfortunately, that group of libraries are only available for Go. So the server side of it is only generating code for Go. But in theory, gRPC Gateway can be extended later to generate server code for other languages. But yeah, for now, if you want to use gRPC to generate REST APIs, you have to stick with the Go language. So yeah, demo time. So I made a demo. I should probably get this link to send to you on the chat. Let me get here real quick. But the idea is to build an API that you can register some catalog entries like your TV shows, your movies, and you can like give a star or put it on your favorite list. It's like a really simple API. Let me just get the link here, and I'm gonna show more details about it. Okay, I have a link here. Let me send on the chat. Oh, I need to log in. I will send on the private chat, and Amanda will send to me. Cool. So what is the TV time API? So basically, you as a user can create an account with your user and password. Really simple, nothing fancy. You can log in. And also, the nice thing is that you're going to be able to log in and get a JWT token, which is a stateless way to do authentication. And we are going to use that JWT token to do some actions on the system that needs authentication. Like, for example, if you want to create a new catalog entry, you have to be logging in. And if you want to remove or add to your favorite list and also list your favorites, you need to be logging in. But for listing the catalog entries, to list the TV shows, to list the movies, you don't need to be logging in. So it's kind of a full stack way to show a more, not full stack, like a full API application that we usually need. Like most APIs need that, some sort of authentication. So yeah, I'm going to show that. So here are these services. So basically I defined 3 services. One is the user service that the user can register itself, can list their favorites, add or remove movies from favorites. Also, there is the auth service that it can log in. And this is the cool part that I mentioned before. For example, if you take the login request here, you know that you need to pass like a username and password, and that is going to return you a token. So it's really good that you can actually define that beforehand. And also there are some returns types. Like if I register a user, I will get like, for registering, I need a username and password again. And when I finish my user registration, this API is going to return a user, and that user have an ID and username. So everything's always like documented. And again, for the catalog service, I already showed that before. I have the methods here to create, list, and also get an item. And there are the parameters that I can use to filter my catalog, for example. So yeah, on top of that, so this was just gRPC. So now with gRPC Gateway, you can add more annotations to make your gRPC your gRPC API available over REST or over a REST API. So here I added annotations to add the URLs of those services. So for registering a user, you have to hit v1/users to list your favorites, like v1/users/me/favorites. So I have all the URLs needed to access those over HTTP. And also it adds some annotations to add metadata to your Swagger files. So if you want to define where are your documentations for your API, what is the name of your API, where is the server that is hosted on, which type of authentication is on. So this is all OpenAPI as Swagger. So it's nice that gRPC Gateway makes those types of metadata available for you to configure on your gRPC API. And here, for example, I'm adding the security requirements for some methods. So for example, to create a catalog entry, like I mentioned before, I added an annotation here to say, okay, this methods have a security requirement, which is to use the bearer authentication that I defined here. So it's the same key here, the bearer or JWT authentication. And the list catalog doesn't have any security requirement. Also, another nice thing, for example, let's say that, for example, I use a gRPC before I want to make a REST API available, I will have to implement both and then implement authentication on the REST API, authentication on the gRPC API. So in this case, I'm implementing just on the gRPC thing. So for example, in this demo, I added the Authentication Interceptor, which is the name of the middleware concept on gRPC. So all the authentication part is being done on the gRPC side, and that bubbles up to the REST API. So the REST API also have authentication because I added authentication on the gRPC API, which is cool. And yeah, so our API have a Swagger UI too, so we can see the methods and etc. And I'm gonna show this live because I imported the Swagger file here. I also imported the Swagger file on Insomnia, which is the test interface that I use to test APIs. And yeah, let me show all of this live. Let me get here. I have the server running here. It's running here on my VS Code. I'm not going to show that much code because I don't have that much time. So I'm just going to show things running. But basically, it's like the server is using a local database and saving things in and providing that interface. So let me get the UI here. So yeah, this is the Swagger UI. It's running from the local server. And I'm pointing to the Swagger file that also that server is serving. So if I access like here, I can see the Swagger file with all the definitions of my server. So this is pretty cool. For example, I can call login. I can call like any method here. So for example, I created a user beforehand. So my username is Álvaro. My password, super secret password, is 12345. And I'm gonna execute, and it returns a token here. And I can get this token to use on other methods. And for example, let's see which methods needs authentication. So they have like a keylog here. So I know that those methods need authentication. So I can, for example, list the catalog without authentication. So I want to list the TV shows, for example. Let me call this one here. So yeah, I can see the TV shows. I use it like a faker library to generate a lot of like TV shows and movies. So those names are not gonna make sense here. But if I try to call like the favorites, like how do I get my favorites? If I try to execute this, it's gonna say that request is unauthenticated. So I can put here my token that I got from login, put the token here, authorize, and then try to call it again. And I have my favorites here. So I can remove my favorite. So let's say that I don't want to use Swagger UI. Maybe I want to use another UI for testing my APIs. I have the same API, the same Swagger file imported here on Insomnia. So I can, for example, let me remove this movie from my favorites. Oops, always live demos are like that. yeah, I remove it. And if I get my favorites here, yeah, each construct's not there anymore. Let me try to create a catalog entry with WandaVision. WandaVision. Let me put on my favorites here and then get my list of favorites, and boom, WandaVision's there. So yeah, as you can see, we have like a complete API with some methods that are secured, others that are not, some are public, some are specific to the user, so I can identify the user if the user is logged in. So we really create like a kind of a full application using gRPC as the foundations and the best parts of both worlds to build a REST API using that. So yeah, that was kind of my demo. And I think, let me go back to my slides here. Yeah, and all the code is on GitHub. I want to, of course, improve the documentation. It's never perfect, but let me know if something's missing. But it's a project that you can fork and build your own project based on it. Consider it as a boilerplate for your own project if you want to get started building REST APIs with gRPC. But yeah, I mean, right now it's using a local database, but you can swap it up and put like a SQL database, a MongoDB, or etc. So yeah, feel free to extend that demo. And yeah, I mean, some reference here. Again, the link for the demo code. The grpc.io website is really good. I have some really good content. The actual library that I'm using here, the gRPC gateway. There's also this guy here, Johan. He is behind this gRPC gateway project. He's really good. One of the talks on this list here is him like presenting this project, and that's how I got involved into that. And he also have a boilerplate to show how to get started. Although, for example, this boilerplate that I built have also like the authentication layer, which is interesting. But his boilerplate has other things that I didn't show it on it. So all in all, I'm saying that both are good. I mean, you can take a look at both, and you can learn more about gRPC Gateway with like some real world demos. And yeah, I mean, that's basically it. I hope that I'm not running too much out of my time here, but yeah, I think that's it. Thank you, everyone, and hope you guys enjoy.
No, you actually went like perfect on time. I'm impressed. And you said it had been a while. You don't give a talk, the first one of the year. So I say you're blessed. Thank you very much for your time and for even bringing a demo so that people could see both the theory and how it works. Thank you so much for doing this for our community, Álvaro.
Nice. Yeah, I mean, always happy to help. And again, folks, if you all want to like shoot me a message, have any questions about this, like let me know, send me a message on Twitter or whatever. So yeah, I'm happy to help. And thank you again, Amanda, for the invitation. And yeah.
Thank you for coming. I saw people writing so many different languages in the chat. It's amazing. Well done.
Cool.
Thank you so much. So if you'd like to stick around, Álvaro, we have other speakers now. Our second one is Jéssica. I'm going to bring her in the call right now. Thanks again, Álvaro. Jéssica, I'm going to bring you on screen now.
Hi, Amanda.
Hello. Wow, you started saying hi, Amanda, as I was clicking on your face. I'm glad timing was right. How are you tonight?
I'm fine. I was working,
Very
but
good.
I'm here now.
Busy. So I see you have your presentation. If you would like to make it full screen so I can share it with everyone. For the people who don't know Jéssica, which is probably unlikely, Jéssica gave her first talk in English at GDG Cloud last year. And after that, she's been giving talks. And it's a pleasure to have you here once again. So
I'm here again. It's a pleasure to be here. Thank you for this
so much.
First.
No, thank you for accepting. So I'll leave you to present yourself and your topic.
Okay, let's go. Hi, my name is Jéssica. Some people know me, but today it's a different topic. Okay, let's talk about data analysis, specifically data visualization. Okay, because information bias, it's used in several situations in machine learning, in data analysis, in economics, but today it's data visualization in several situations. Okay, let's go. This talk today is affirmation bias and data visualization. My name is Jéssica. I'm machine learning GD. Let's introduce myself. My name is Jéssica, data analyst in Rio de Janeiro, Brazil. I am machine learning GD, master student in computer science, first fit RJ, and bachelor degree in information system from Federal University of Sergipe. I'm studying so much. So I love so much cats, dogs, pets in general. So hello, everyone. Good afternoon from Brazil. Good night, London. It's 5 p.m. Brazil.
It's 8 p.m. here. I think it's 8:30.
At night. So what is information bias? First, I use it in a reference. I like so much reference. And the final presentation, I put links, okay? According to Catalog of Bias Collaboration, bias that arise for systematic differences, emphasize difference, and collection, recall, registration, and treatment of free information used in a study. Okay, it's important to emphasize collection, recall, registration, treatment, because it's related with studies. We have many studies, but it's data. We need to know this data to avoid bias. Information bias can affect data visualization. Data visualization is an important task and data analysis in general, okay? So where do we find the bias? Bias can be found in samples, mainly samples, okay? Because in studies, we work with samples to make inferences, conclusions, hypotheses. So samples very important every study because it's difficult to work with a population. So we work with samples, and samples can be biased. Other situation, data transformation with many outliers. Outliers is important task to work in data preparation because outliers influence so much in results and in conclusions to make decisions. Missing data generate bias too. Database is not representative of a population. Remember, it's difficult to work with population, so we work with samples. And database not representative generate problems. Okay? Misinterpretation of statistical values. In studies, we generate statistics, descriptive statistics and inference statistics. But the misinterpretation causes problems and bias too. And finally, visualization of biased data and visualization too. Okay. But before to talking about visualization, two concepts are very important in data analysis and visualization data and machine learning models and several situations. Correlation and causality. Okay? Correlation is a statistical relationship between two variables. It's a metric. Correlation is a metric. We have correlation linear correlation, or no parametrics, but correlation is a number. It's a statistical metric. But causality is different. Is the cause and effect on a relationship. Okay? But a question. Does relationship imply causality? No. This is a logical fallacy called post ergo propter o. After that, soon because of that. So it's a problem because in several situations, people use correlation causality. It's the same thing, but no, it's different. But some causal relationships can be correlated, but not always. Correlation linear, for example, we have positive correlation, zero correlation, and negative correlation. But this matrix doesn't imply a causality. Okay. For example, we have an example. It's a spiral correlation. Spiral correlation no makes sense. Okay, but some people can use it. In this graph, for example, we have a divorce rate in Maine correlates with per capita consumption of margarine. Divorce rate in Maine are high, and per capita consumption of margarine are high too, but are correlated. They correlated? Yes, but don't exist a causal relationship. Okay, but we are correlated, but not a cause. Causality don't imply a correlation. Okay. After this conversation about correlation, causality, we have finally data visualization. Data visualization is images. It refers to the techniques used to represent data. You can represent data in several ways. Images, tables, or figures, videos, but in data visualization, one of the ways to represent is through images, or like graphics, or other ways. But data visualization is an important task, mainly in data analysis. And in another task, storytelling. Many people talking about storytelling. It's telling a history, narrative. But it's a fundamental element. When you do a storytelling, data analysis is a fundamental element. We're talking about this. Other topic is a Gestalt psychology theory, using in other science, but we can use it in data visualization and computer science. Has some principles that explain how our brain perceives things, how our brain works. We can apply in data visualization using Gestalt principles. Let's analyze. First, storytelling. With storytelling, we have data. When you use a storytelling, we just explain data. You represent this data. Not only see data, but explain this data in some scenario and to people. When you use data, when you show data, you represent, you show to people. So we need to explain. Explain why? Because people make decision through data. Okay, so what's the element important in storytelling? Data, narrative, a history, and visualization. This is storytelling. 3 elements very important to telling a history. And finally, Gestalt. Gestalt is used in psychology, but we also use in computer science and data visualization and other science. Are 5 principles, okay? The visual perception. Visual perception depends of our brain. Our eyes see, but interpretation is brain. Okay? And what's these 5 principles? We have proximity. Our brain works with proximity and between elements. Closure. The brain's good in filling in gaps. Our brain is very smart. Continuation. Continuation is an element very important in our interpretation of reality. Okay? A line will always appear to continue traveling the same way. Continuous lines are easy for our brain. For example, similarity. Our brain works so well with similarity between elements. Okay, 2 items that share attributes will be visually grouped together. Our brain do this. Groups. Figure ground. Sometimes the blank space is just important filled space. Our brain perceives blank spaces. Our brain is very smart, but these elements are important when you construct a graph, for example, because you see, but your brain understands. Remember, you see, but our brain understands. Let's analyze a graph. In this graph, you have Bank of America, Chase, Wells Fargo. It do not use major bank. So in the first Bank of America, we have 13%. This bar is high. Pay attention. In Chase, we have 10%. This bar is high too. Wells Fargo is 10%. It's high. But do not use major bank, then 52% are high, but are similar. Everything are similar. It's the worst to our brain, because it will understand the same way. It's similar. So Bank of America is similar. I do not use major bank. This graph are not clear. It's biased information, because our brain will understand Bank of America is similar, do not use major bank, but do not use major bank has 52%. It's bigger. It's bigger than Bank of America. Bank of America is 13%. Is a problem in data visualization. You can find other problems in data visualization in colors. For example, red is not a good color to represent data, positive data. In general, our brain understands yellow, for example, like an alert. Brain like a danger. So Be careful when you use these colors in your graphs, like red, yellow, green. These color problems too, because our brain understands them another way. Remember, other situation in graphs is a problem in the chart general bar. She need be proportional. For example, 13% are not proportional. But if you see only this figure, these bars, you understand that Bank of America is similar, do not use major bank, but not. It's a bias data and data visualization. This situation happens in elections, in studies. You can manipulate information to graphs. You find several graphs with problems, sometimes intentional, like election, an example. Because manipulate information through data visualization is easy. Many people don't analyze numbers, only colors and figures. So it's easier. See a figure and make conclusions. But analyzes figure, colors, alignment, legends. Another topic important is about legends and graphics. Need to put legends clear, easy to understand when you construct our graphics. Ok, então let's resume this main information. First, be careful with colors and graphics. Okay, first. 2, make graphs proportionals. Okay, numbers, proportionals, and figures, proportionals too, to make to represent well this data and the truth. We need to compromise it with the truth, with make decisions clear and based on clear information and information important, information studied, information comproved with comprovation, with good conclusions. Okay. Third, be careful with numbers and legends. Okay, this topic is important, how to construct our graphs to avoid bias data and data visualization. And a conclusion in this topic. First, bias in data visualization can be intentional or not. Sometimes it's intentional. Okay, so be careful and analyze your information when you see in journals, in newspaper, and television, and internet. Be careful with internet, because many people manipulate information in the internet, mainly social media. When you construct a graph, you can manipulate information through colors, to disproportion, and other ways. So be careful and pay attention. Analyze this graph. Analyze this information. Verify sources. Okay. Important to pay attention to the principles that explain our brain understanding. Okay? Our brain understands the world. We see data, we see images, but interpretation is brain. So, yeah, it's important to understand these principles. Gestalt: proximity, similarity, closure, continuation, figure and ground. Apply these principles in your data visualization and your works with to pass a good information for these people. Use representative data and be aware of spurious correlations. Let's go back. So, spurious correlation. No makes sense, but some people can use it. An example, and vaccines. Some people are using spurious correlation in vaccines. So, I feel sick, but it's a vaccine. No. Can exist in a correlation? Yes, but not causality. It's different. Correlation, remember, is a statistical metric. It's a statistical relationship and two variables, but causality, no. It's another example. Vaccines, remedies, medicines, and atmospheric phenomena. Be careful with correlation. It's spurious correlation. Because this is a bad conclusion. Storytelling is about how you present the data. Let's go back. When who works with data needs to present this data for people, for conference, works, articles, and to people understand the data, you need to tell a history. It's scenario. Your data information exists when you have a data and scenario. Okay, data apply in a scenario. You have an information. When you have an information and apply this information, you construct your acknowledgement. So storytelling is very important. You remember narrative, telling history, data, and visualization. Our to teach an information, a study, you can use several approaches. You can talk. You can represent figures. You can tell a history. Several approaches to teach. But humans learn more with use several ways to teach. There are several studies about this, about teach, about information, and about human interpretation. It's important to understand the data and statistics before sharing information. It's complicated to speaking about this topic because you see, I see many people using statistical metrics to share bad information. Because a statistical matrix is related to studies, experiments. Okay, so when you see a matrix, a statistical matrix, you need to pay attention and study and experiment and experiments and results and conclusions. So be careful with that, because a matrix is only matrix is nothing. But in a scenario, in experiment, you have information. So be careful before sharing information. For example, today we have a terrible problem with social media, because people share information about its efficiency. It's true, it's not, because it's a 52%, 10%, but they does not understand this data, because they see a data and a number and don't know apply this number in a scenario, an experiment. You need to understand the experiment to make conclusions. So be careful sharing information. Okay, understand your data, understand the statistic, inference, the methods, and size. We need to understand methods too. Not only numbers, many methods, methodology. True. Okay, it's my advice for you. I hope so help you. I hope to help you. And some questions, can talk to me in my Twitter. This is my reference. And I like so much this figure, and I would like to read this. I used to think correlation implied causation. Then I took a statistical class. No, I don't. Sounds like the class helped. Well, maybe. It's important to emphasize this. We need with doubt, with hypothesis. Okay? Science works hypothesis. So be careful. Thank you. It's my Twitter if you talk to me. And good night, London.
Good night, Brazil. Thank you again for sharing your knowledge and your time with us, Jessica. So people who were asking the questions here in the chat, you can reach out to her directly on her Twitter, and she'll be happy to answer your questions. Right, Jessica?
Okay. We have questions here.
I would like to take them here. Okay, let's have a look. So Peter said, love the margarine example. Very important concept covered with humor.
Divorce and margarine.
Issue in visualization. Good way to show 13% is very close to 52%. News channel use similar way to show data. Do that changes depending on the market you are presenting the data? For instance, other cultures attribute different meanings for colors.
Yes, Katerina. Depends of market too. But for example, it's for yellow. Yellow in general, it's alert. You can use, yes, but careful. You can use it. Is no. Yes, you can, but be careful using in situations, in some situations. But because colors and graphs can cause a bias data. For example, the red causes this. It's red, it's bad. No, but maybe not bad, but our brain understands it this way. Don't be careful. You can use, but be careful. IT, XKCD, perfect. I love so much.
People seem to have loved your talk, Jessica. Thank you again. We
That's
have
a question here. What is the best?
one more question. Let's see. What is best, heat maps or bubbles for visualization?
Depends. Both are good. Heat maps is good to differentiate, and bubble is quantity. Bubble represents quantity in general. Heat maps is good to represent correlation, for example. Heat maps perfect to represent correlation. I use in my work heat maps to represent correlation relationships between variables. Heat maps. Bubbles I use to represent quantity. But both are good.
Thank you very much, Jessica. There's many questions, but we still have 2 more speakers. So if you have any further questions, please reach out to Jessica on her Twitter. Thanks again, Jessica.
Thank you so much.
So I'm going to invite the next speaker now. I just wanted to let you know before we do so that I have some licenses, some JetBrains licenses to give away. So if you're on Twitter and you tweet at GDG Cloud, I'm going in the end of this presentation to give live a license to a couple of people. So I'm going to invite Will now. Hope you're ready in there. Hello. Hello, and you're muted. That's the sentence I say the most in 2021.
Hey, now for real.
What a pleasure to have you here.
It's a pleasure to be here as well. So, how are you guys doing?
Yeah, all good here. Here in London, it's 9 p.m. So people are up late to listen to you. I'm going to bring your talk here, okay? Can I share it?
Yeah, absolutely.
Cool. So I'll leave you to present yourself and your presentation.
Right. So first of all, thanks everyone. Thanks Zilanda for the invite, and thanks Amanda. Thanks everyone. First things first. So my name is Wilson Mendes. It's quite weird when I mention Wilson. Looks like everyone just called me Will. But anyways, I'm Google Developer Expert, Web Technologies and Angular, MVP, Developer Technologies, Atlassian. So the content of this talk is just sharing some points and insights and caveats and some things that I've been working with during my project at Atlassian. It's called Performance Analytics and Reliability on Frontend Apps. And I'll share some stuff about why those points are important, and more than these, how can you use and add some of these characteristics and attributes and toolings and all the stuff that can make your web apps nice. So yeah, this is me, as I mentioned before, and let's start the party. When we talk about performance, which will be our first point, we always have in mind is something, okay, how fast that could be. So I always love to start this discussion with how long is 2 seconds. Maybe it's too much, maybe it's too little. So it really depends on the scale they're working with. For example, 1 second delay in mobile can lead your conversion to be decreased by up to 20%. This is a research made by Google. We have this link here at the bottom if you want to know more about it. Just a reminder, I'll be sharing these slides with GTZ London and also be sharing on my Twitter. And also talking about performance is always related to the feedback that you have, not necessarily the feedback that takes to the back end to talk to API or how fast it is to have that amazing animation. But more than this, how is the impression for the user? So we have these 4 pillars. The first one is it is happening. And the second one is it is useful. The third is delightful. Those are related to the user-centric metrics. So for example, if you think how long it takes to the user navigate to your page, and you understand that you navigate between pages, it's happening. So that's the first topic, the first pillar. If you're talking about, okay, I'm how long it's taking to go to one page to another one and click in a button. It's useful. And it's the life is the one that everyone wants to achieve, that like everyone's happy and use your apps and being really enjoying the experience. From the user-centric concepts, the pillars, to the user-centric performance metrics in a code, it is happening is quite connected with first paint and first contentful paint. At first, we have here the page, so it's pretty much blank page. First contentful page paint is related to the first in your page. In that case, it's a loading. First meaningful paint, something that the user can see at first. In this case, it can see some information here at the bottom. And the time to interact is related to the time, how long it took from the first paint until the time that the user can really use your page and navigate between pages and click on links and see some images, perhaps a gallery, and those kind of things. Talk about front-end specifically. When we think about performance, we always think about the bundle size. And when we talk about bundle size, we need to always think about budget. Why this is important? Every time that you move between a page to another, probably your browser probably is loading some files. Can be JavaScript, CSS, HTML, maybe doing some API calls. And those are the ones that we call budgets. As an example, if you have a file that's too big, maybe your page is slow because of that. So there are a few techniques to improve that, to make that faster. Some budget, if you think about it, and that here we have few points on the table, and the size of JavaScript should be less than 170 KB. So this is quite important. So it's more than this, you're probably in trouble, and you need to work as soon as possible on your page and your files to decrease. Lighthouse performance score should be more than 80. This is quite relevant since Lighthouse is a audition tool, so you can get information about performance, accessibility, and all the best practices that you can apply in your page. And now, talk about scale. When I started, I just asked how long is 2 seconds, how fast is 2 seconds, how slow is 2 seconds. For Google renders his main page in something about 1.2 seconds, and Amazon loads the home page in 1.4 seconds. Those are massive applications, and they are rendering the pages in less than 2 seconds. So that's insane. That is how powerful and how important is performance for those players. Now back to our reality when we had it at Lazen at first. Here we have just sharing some good insights about one issue that we got in the past. And this issue was solved, but it's good to mention because that was a really good one. We had this error here, this green arrow saying the company page is ready to be rendered, and the red is rendered. That means that between the red and the green one, we had 2 seconds, 2 seconds with a blank page waiting to be loaded. So those are the points that I need to care about. And because of those graphics and this monitoring that we add in our page, we were able to understand more and work on this issue. So always get some data. And yeah, talk about performance. Everyone always like to talk more about 5G because 5G is quite fast and can solve those kind of issues, right? So let's take a real picture of the internet around the world. The first thing, how fast is the 5G? If you think about 5G right now, 5G is between 10 to 100 times faster than 4G, which is amazing. It's like pretty much sick. But however, we don't have a full support around the world. It's not every country who has 5G, and even in those countries, we don't have full 5G support. Those are the points that we always have to have in mind when we do applications. This is a good graphic sharing between the difference between 5G and 4G with some players and providers from US. As you can see, we have a massive difference. And here at the bottom, we have a link if you want to know more about this research. So 5G is really a thing. If we have that across the globe, that will be a massive achievement, massive improvement. Or for example, if you want to talk about this data with someone who's not technical, that can be a good way to share. Okay, if you try to do of Game of Thrones in 4K using 5G, it would take 90 seconds or 35 seconds if you wanted to have a 1080 pixels. Or if you want to just download the whole season, it would take something like 15 minutes. So that's what the 5G is bringing for us. However, that's the picture that we have when we talk about internet around the globe. As green as we have, as dark as we have a good and proper connection, and as lighter as we don't have a good connection. As you can see, we barely have darker places around the world, so few countries who have some amazing connection. So that's something we always have in mind, and that's one of the reasons that we always talk about PWAs, progressive web apps, and how to improve those applications, think about performance, so on and so forth. But more than this, Google now is showing to the users that that page is slow. As you can see, this yellow box, when you go to a page and the page takes too long to load, you see something like this. Loading usually loads slow, and also that will be one of the points that will be decreasing your ranking when someone look for your app, look for your site at Google. Okay, now let's think and let's understand how we can measure performance. The first one, let's define some baseline. If you don't have any baseline, you need to start with something. If you want to measure, you can measure different things, not just performance, but also the user journey or even the page load errors that you can have. In this example, we have 2 lines, and the green one is the one with the errors, and the blue one is the one with the success. Right? But we have green and red. In that case, it doesn't matter. Think about accessibility. Think about that we have people with some disabilities that cannot see red, they cannot see green, they cannot see specific colors. So for them, what matters is the contrast between those colors. But yeah, you need to start with something. If you don't have an idea, try to list the errors, because as much as you have errors, as much as you can work to solve those. Also, another approach is use real user monitoring, so that you can understand how long it takes your browser to respond to your users. How long it takes since the moment that the user types your website on the URL until the moment that the page is loading. And also you can have a good graph sharing from where they are accessing. What else can you do? Load components so that you don't have the file with everything attached at the first time. That's quite useful for things like you don't need to load at the first moment. Let's say if you have a menu with items that are not loaded because the users are not clicking at that piece that much, or even a gallery of images, you can load that component asynchronously. Another approach, critical path. Critical path is something really important, so it can improve your numbers when you talk about page load and first paintful content for paint. That technique is used to extract the CSS and HTML that's extremely required at first load. So the user will see, let's say, a loading at the moment, so that will be attached, and otherwise will be loaded asynchronously. Optimistic preloading. That's a technique that you can use for things like gallery and other stuff. As an example for gallery, think that you have a gallery with 5 images. You have the big one at the middle, and when you click in the arrow to the right, you can load the next one. And when you click to the arrow to the left, you can load the previous one. But this one way. With optimistic reloading, you can start loading the image as soon as you add the mouse over, so you can have that in advance. Or even if you're in image number 3, you can have image number 2 and image number 4 preloaded. So for the user, that would be transparent. But for you and for application, that will be way smoother. Way smooth. And setting performance budget. If you don't know what performance budget is or how can you set, we have this page sharing everything that you can have. So for example, if you want to have a file that takes up to 60 seconds to be loaded, you need to have 300 kbytes at maximum. So those are the points that you can measure. So more than this, let's say if you have a file which is 100 kbytes, you can define the threshold. Every file should have, as example, every file should have no more than 200K. And if you do, you can break the build, for example, in your CI, in your CD, in your pipeline, so that the developer can have a faster feedback, avoid issues in production, and work in advance. That can be solved like if you create a component that could be loaded async, that can be a solution. Okay, we have a lot of techniques. We already have ideas. We understand a little about performance. But what if we miss something? We always can miss something. Okay, bundle size feedback. As I shared before, we have the performance budget, but we always can think about the bundle size, the files and assets that we sent to production, and how easier we can get this feedback. One way that we can use, and we are using at Alazen, is comments and pull requests, but not comments made by a human or a team member. We have some automation, so as soon as you open a pull request, it triggers a task to do the bundles, to do a build, and gets all the values for the bundle size. Why your file got increased or decreased, and what can you do? When you do that, think always in the main bundles. The main bundles are always the ones that are loaded across pages. So those ones shouldn't be more than the threshold that you defined. And with all this information, you can take some proactive actions. For example, if you see that you've been increasing a file for 5% every time someone opens a pull request, you can have a look and understand what's going on. And yeah, now that we have everything, we can also have performance as a prioritization. In our case, what we defined was a performance degradation is always a production issue. So let's think in a scenario. If you change something and you deploy to production, and because of that, it's taking more than some specific back that deployment and work on that, so that the users shouldn't be impacted by your changes like that. And we should have metrics everywhere, pretty much. But now we should have metrics. We should have metrics everywhere. But which metrics is the best for my app? Let's start with Just an example. Let's think that you have two components that will be loaded by some feature flag. So here we have a sync module, and if the feature flag is turned on, in this case, we are talking about a navigation, a menu. Flag turned on, you can load the navigation next package. Otherwise, you can load the old navigation. This is really good for things like progressive rollouts and those kind of things. So you can have an easier way to validate and deliver the new navigation for 10% of users. I'm talking about the new navigation, but it can be any component that you have. Or if something goes wrong, you can just turn that off. So you can solve that issue in production in seconds. In our case, it was just a small change. But in our component, to do that, to make that work, we have this. We are using React. So in the render event, in the life cycle, we have, if we don't have navigation state, that means we are not loading the file. We're still loading the file yet. So we have returned the skeleton. Just a piece of HTML saying that, showing to the user that something will be loaded in that placeholder. And if it's loaded, we can load the new navigation. But in that case, why can you measure? Should you measure the React piece? Should you measure the feature flag logic? If you're not sure, just measure technology. The users for the users, they don't care if you're using JavaScript, if you're using Node, if you're using Java, if you're using Golang, or any other language that you have. They care about their experience. So for them, long story short, for them, if the page is fast, that's what matters the most. So if you're not sure what user experience is always the king. Second step, define architecture. In our case, we define with this, so we have internal analytics platform. So the page we would send some payload to one internal API, which is a facade, reads that content and sends through our analytics platform pipeline. That data will be manipulated. It will pass for some MapReduce and be standardized, so can be used in any platform that we have. So we have integration with SignalFX, Google Analytics, have with any other because of this analytics platform abstraction that we have here. But one of the case, if you don't have internal analytics platform, okay, you have different things that you can use. You can have Calibri, Speed Curve, Firebase, New Relic, web page tests that are different to check the performance website using some automation and use some third parties. Some of them are cheaper than others, but all of them are worth it to have a look and integrate your website. So you can get good sites and work in advance in any issue, not just the performance issues, but it can be anything as long as you had some. In general, when we talk about web apps right now, we're talking about this architecture. We have components. A composition of components can create a page, and we have our routing to move from a component page to another component page. This routing can be a server side. At that level, it doesn't matter that much, but that's the architecture that we have these days. But now, when you go to the page, in our components, for example, when you try to upload a file in Jira, you go to the pop-up that opens, and we can see every event standard that with our standard. So we have, for example, this media card render, and we can understand when the component was commenced. The commenced is when the component starts to load some files, and when we have some success and some errors. So every image that we have here in the pop-up is one component, and we have the tracks for those. That means that if you have a lot of errors when you try to load the file, we raise some alerts and people start to look into those. Okay, chaos scenario. That's a good topic also. A crazy scenario that we can have, so that can elaborate more about the chaos. We have this function called fire error analytics. With this function, you can pass some payload to define the type of the error. It was an error based on track, based on UI error, or any other that you have. The error itself, any relevant information that you have for the error, and attributes. These attributes is something that can pass to define some specificities about your component, about your product, about your integration. I think that you have a class to catch and report errors, and every time something goes really bad, you fire the analytics and keeps throwing the error. So the main application will get that error, but before that, you're sending that to a platform. Internal platform can be a Google Analytics or any other platform that you have and using for some log analytics purposes. This is quite useful, so you can avoid to don't be aware of things that happen in production. So okay, we have everything covered in the front end right now, but what if your API goes down? Or more than this, what if your API have optional attributes? What if your types are not assertive? Everyone talks a lot about TypeScript, for example, when you talk about front end, instead of doing JavaScript, doing TypeScript, or even Node, when instead of doing Node.js. But if your types are not that assertive, for example, if you have this API called API/endpoint/1234 and returns a location with an array of items, but your type definition for that is saying that everything is optional. That means that location is optional. It's an array. In listing, which is something that's not there because it's optional. But when we have, it can be an object with pretty much anything. What happens if now you have location in listing? It shouldn't be that bad. It can. It can be maybe it's waiting for listing and expecting the listing is there every time. Those are the points that you have to manage in your front-end components. Make sure they are resilient, and if the API doesn't return the data, not just the API is down, but if the API doesn't return the proper information, you will never see this page. Okay, now we know a little about chaos. Let's create some. Before prediction. So yeah, chaos engineering doesn't cause problems, it just reviews them. That's a really good phrase from Nora Jones. She's a chaos engineering lead at Slack, and she's a great advocate of the chaos engineering across companies. The main goal of chaos engineering is not to create problems or break stuff. It's more to understand that we have a problem, understand the level, the severity of that problem, and work to solve that problem. So how to create some chaos? The first point is plan it. Try to plan as much as you can, so you won't have any issues in your script to understand saying about some tooling, but more to understand what would be the scenario that we try to simulate. Prove your hypothesis. So you can, let's say, if you think that a file, the API that returns your files might break a lot of things, you can try to prove that hypothesis and work on that. and define boundaries for a case. For example, if you work an API that will return files, try don't break anything. If something else breaks, it's not because you're changing two places at the same time. Try to have focus, so you have the boundaries of that or your test. And yeah, we have some tools for case. For Chaos Monkey, if you talk about backend, so you can try to simulate what happens if a region goes down. If you talk about AWS or Google Cloud regions, or what happens if a Docker container is not healthy, and those kind of things. And we have Gremlins JS. The way that Gremlins JS works is pretty much like that. You define the script what needs to be done, and it does a lot of things. And at the end, your page shouldn't be broken. That's a way to avoid people to doing that manually, and you have a script to run that every time. That can be used locally, pipeline, and you can point to any environment that you have. Also, another thing that you should have is as soon as we had in our case, as soon as we had all the analytics information, the payloads, and we add all the instrumentation production, we always have support for Arnot's monitoring. So this is a example of a detailed metric, sharing the upload success that we have, how any issues that we have, the token timeout, and anything that's relevant for us. And as soon as we have those values being decreased for a certain threshold, we are receiving alerts and we have to work on those. So that's good because it creates awareness and you can solve this problem in advance. And keep always the good work and try to be alert as much as you can. With all that you have here, you can work proactively on your caveats. So before the user goes wrong, you can work on those. And more than this, now you don't need to add some metric and measurement only for the technical aspect. You can understand, for example, your users. Let's say the user journey or even a user experience. Let's put an example. You have a file, and when it takes something around 3 seconds. If it takes something more than that, it's an issue. So before the users get that, you already got the alert and you already work on that in advance. Because that can be maybe a deployment that you did in your back end, for example, and that can be possible. And more than this, now we have all the toolings, everything to do some A/B testing measurements with more confidence. As an example, we have this dashboard to validate different approaches to upload the file. So as you can see, we have some good sites and how the users are doing their uploads and which technique should we keep and which one should be removed. For front-end instrumentation and back-end instrumentation as well, if you work with Node, you can use user time API. User time API, it's a built-in API from JavaScript that can get you some good sites. In our case, we add some abstraction because user time API has some different ways to work between JavaScript, the front end, and the back end. And to make this smooth for developers, I created a package called here is the way that we use in the front end with the built-in application. And how you can see here, performance API is something that's well used across all the browsers. But we have some specific ones that we can have some issues. But in KNIUs, we have this. And in MDN, we have this information. So they are not connected. That means that if you use that API in production, you can have things like that. And that's a true story. We tried to do something that was working in Chrome, but wasn't work in Safari. and we had a production issue. To solve that, I created a package that I mentioned before called perfmarks, and we have all this abstraction, this browser validation, and we have a smooth way and simple way to work to use that between front end and back end. How that works. First, you can just export the package. It has entry points, so you don't have to increase your bundle that much using just what you need. You can call perfmarks.start, and you can call the mark, create a mark that you have. You can execute something, and after that can create another one. And when you call get entries by type, you have everything that you need, all the information. That means that you can have that same code will be working front end and back end. In our example, we are not just getting that to understand more about the performance of apps, but we also get that instrumentation to understand the user conversion. Let's say how long it's taking. In this case, I'm showing how long the user has the gallery that we call media viewer opened. So we can understand more about the user, their needs, and what we can do to improve this time, improve their experience. And yeah, next steps. Or, okay, now we have measurements, and this will drive us to faster UX by design. Yeah. At first, this whole approach was used because we are adding a new navigation and across products actually. But at first we added Jira, and after that we added Bitbucket and Confluence. But now we have this connection of this concept, this idea of performance shared in the company, and now designers are also concerned about performance. That means that every piece, every new component, and every new prototype, they have some performance concerns on their core. As you can see, we have here at the bottom a previous navigation. It has a lot of animations, icons, and stuff. And based on the data that we got, we made a data-centric decision. So we are moving to another menu here, way cleaner, way simple, and it has everything in the same spot. For the users, it's great because it's faster, it's cleaner, it's easy to use. For us, it's great because it's performatic and it's so yeah. That's the journey that I like to share here. I hope you folks enjoyed. If you want to know more about some cases, the case of some companies and how they improve their performance, that's the website, WPO Stats, so you can have a look and get some good. Also, those are the links for the project that I shared here. And if you want to know more about performance in general, you can go to web.dev/fast. And yeah, that's it. Thank you, folks. I hope you folks.
Thanks again for such a great, complete presentation, all for free for the community. We are so lucky to have you. Thank you a billion times, Will, and have a lovely evening.
You too. Cheers. Bye-bye, everyone.
Bye-bye. I'm going to invite our next speaker now. And he's already here with us. We have Vinicius. Hello, Vinicius.
Hello, Amanda.
How are you?
Good. I'm good. And thank you for having me.
No, thank you for coming. Is it your first presentation this year, or?
Yes. It's my first one.
Excellent. We're super lucky. I'll leave the stage to you.
Oh, thank you. Thank you again. So, hello, everyone. So, okay. So, my name is Vinicius Carida. Nowadays, I'm a manager of digital customer service platform, data and AI in Itaú Bank. Itaú is a Brazilian bank and largest private bank here in the South America. I'm also an MBA professor at FIAP and Google developer expert in machine learning. Please, if you'd like to have me in your own network and talk to me later, follow me in the social networks here. So, normally I start my talk with this slide because it's a little bit joke, but some company think that to become data-driven is just have data in any format, hire a data scientist, some magic happen, and the money flows. But we know that in the real world, it's a little bit complicated than that, and you need to build some platforms and some process to help us to really get the value of machine learning on your product. So today I will give us a little introduction with what is MLOps and the TFX platform from TensorFlow, TensorFlow extended. So to start this concept, I will talk first about the DevOps. I think and developers know about this culture and practice about DevOps, and of the main concepts is try to unify the software development and the software operation, the dev and ops. And the most important here is to have a strong advocate in automation and monitoring and all the steps of the software construction, from the integration, testing, releasing to development and the infrastructure management. So the DevOps is a very famous concept, and it's famous because you can see a lot of changes and big wins in the companies. So in this report, the state of arts report, state of DevOps report, you can see, for example, the companies that use this methodology increase 46 times the deploy frequency and faster time to market, 7 times lower change fail rate, more than 2,000 faster lead to time for changes, increasing revenues, and more than 2,000 times faster mean to time to recover. So the DevOps having giving the company very good results. So, but what about the machine learning in this concept? So, as you can see in around the world, the machine learning, data sciences in these concepts are becoming the more core capabilities for the solve complex real world problems. So, and the industry are investing a lot of money in building data science teams and ML capabilities. So, but even that, even the concept is very famous, is very topic and hot words in the world, and the companies still put money in this field. A lot of companies still have difficult to generate values with AI in the real world, and it's in what it's happened. Normally, in the academic field, you can see a lot of research evolution. For example, I think the most famous in the last months is on GPT-3 algorithms that you can use this in the natural processing language to generate answers and have a good understanding for the natural language. So GPT-3 was a very famous algorithm released for the OpenAI. But one thing is building and testing new algorithms in research fields. Another thing is using this to improve a product, a process, or something in the real world industry. So to have this value in real world, you need to improve all the maturity of these operations. So another fact here is that more than 87% of data science projects never make it to production. It's a very big number of the projects that cannot make it in the production, so in fact don't make value for the companies. And it's happened because normally the people think that the model, the code of the model, the training the model, it's a most important part of the solution with machine learning. Of course, it's a challenge to build a good algorithm training and so on, but this is just a small part of this big engine. So the ML code is important, but you need so much more requirement to take this code and put in the production and really take the advantage and bring value for the company. So it's best about the configuration, data collection, feature extraction, data validation and verification, to management the resource of machine, infrastructure, monitoring, and so on. So it's a very complex platform to have your machine learning models in production. So for the companies, it's very important to have this complexity in mind and think how can we can build some platforms or build some strategies to avoid these complexities. So I very like this these 4 concepts that was released for the Andrew from Big Head platform from Airbnb, that he said that you have some intrinsic complexity within machine learning models or machine learning fields. So, for example, to understand the business domain, selecting the appropriate model, selecting the appropriate features, doing the fine-tuning from the models, these 4 things is a intrinsic complexity. So, to solve these complexities, you need some good data scientists, data engineers, and so on. But Andrew told us that you have some incidental complexities too. What it means about incidental complexities? It's about something that you can avoid if you have a good and strong platform and good process. So you don't need to have this complexity in your day. So what kind of complexity is that? It's about integrating with data warehouse and offer data from the company, scaling the model only in training and serving models, keeping consistency between prototyping and production, training inference. It's a very common problem that you have in the real problems. When you're prototyping, you have your FU score like 95% of the accuracy, and then when you put it in production, your score having down, and you don't know why. So it's very important to keep this the consistency between the environment, keeping tracking of multiple models, version, experiments, and support iteration on ML models. So in big companies, we have a lot of models in production. You need to support an organization of all these models. So, okay, so I start to talk about DevOps, and then I talk about machine learning, and what is the relationship with these 2 topics? First one is because machine learning models we start with, you have a code view. You need to programming too. So when you're looking for the writing a software or programming, you have some issues here. When you here you have some difference when you're programming in a small or project or your own, or in a large project in big companies. So we see more often in small projects you have a monolithic code, non-reusable code, untested code, and so on. And in a large company, the companies try to have a more modular design implementation, libraries for reuse, well documented contracts and abstractions, and so on. And when you shift for the ML world, in the code view is the same. You know, if I come back to the previous slide, and software and ML view, it's the very same. You have the same questions here about the writing the ML code. But when you talk about the ML, you have more things to have in mind. For example, data and other artifactors. For example, you need to involve about the data sets, features, and the objectives, reused models, measurable statistics, problem statements, discovered artifactors, and so on. So now, what is MLOps? It's a combine from the modern software engineer, from the DevOps things, and more than machine learning development. So MLOps philosophy, you try to use the modern software development like scalability, extensibility, configuration, consistency, modularity, best practices, and so on, plus labeling data, feature space coverage, fairness, recondition, and all the things that you need to concern about the data, the privacy, and everything. So how can I use the machine learning production and have all these concerns in one platform that help me to develop and put into production the ML system? So here in this slide, we have some ML life cycle, and always you start to define and understand the business use case. Then you go the step 2 when you start to the data acquisition and explore the data. Then select the algorithms, building the data pipeline and future engineer, building ML models, evaluate these ML models, and if the evaluate is not so good, you come back to the beginning and start again to understand the data, use case, etc. So if in the step 6 the evaluate was good, so we start to present the results, doing the plan to deployment the model, operationalization the model, and of course monitoring the model. In monitoring here is a very important thing, because you know that monitoring the software, it's not so easy, because normally the users doing things that you cannot imagine. But in the ML field is more complicated, because the data that you use to train the model can not be the same the data that you are having in the process in the production. So the model, monitoring the model, is very complicated task here. So how can I build a strong platform that help us or allow us to have a good pipeline, end-to-end pipeline, to building, testing, and do all this best practices in the ML world? So Google have a platform inside the GCP. This is AI platform that you have a lot of services here that allow us to have a complete end-to-end pipeline, starting the ingestion, storage, the data, preparation, and do the future engineer, data warehouse, and then put this model in the production. It's a very strong integration platform that help us to build it in the GCP. And you have also the Collab. It's a very good free platform. You have a Pro Collab, it's a paid platform, but you have a free version, and it's very useful for testing your models, your codes. So Google have this entire platform that help us. But if you'd like to have a flexible platform and you don't be just use in one kind of cloud platform, you can build our own platform. But Google also have open source research to help us to build our own flexible end-to-end ML platform. So this flexible platform calls TFX, from TensorFlow Extended, and this framework have a lot of best practice libraries, binaries, codes, components, and pipelines that help us to build our own process to have our machine learning end-to-end platform and use it in on-premise infrastructure, Google Cloud, or any others infrastructure that you want. So when you think in the end-to-end platform, you need to start in the data ingestion, because data is our fuel from the ML things. So then you need to do the validation from this data. For example, if you have some missing value and if you have some things that you don't know, then transform this data, for example, normalize, doing some embedding things, transform number in the category features or category features in numbers, and so on. Then training the model to see and the weights that you need to learn. Then analyze the model of this accuracy, FU score, IUC curve, and another one's analysis to know if our models it's okay. In both of sides, in the test data set, in the training data set. And once the results was good, when you need to push the model in production and serving this model in a lot of environments. So sometimes you would like to do the predictions in the mobile fields, and so you have the TensorFlow Lite to do that. And sometimes you'd like to push the model in the web. So you have the platform, it's very flexible to do it too. So to give a little bit more example and don't extend the time, I know this event today was very good, a lot of information. I will pass very fast here, but just to have to realize how can a flexible and open source tool can help us to build our own machine learning platform here. So when you talk about the machine learning process, you have a lot of things to do. And the first thing is you need to management this process. So for do this management, you can use Airflow, for example, or Kubeflow. It's another open source tool from Google, and so other tools that you like. So then you build our process. For example, starting the TFX data validation, TFX transform, and so on. And then each one of this process, each step of this process will build some ML metadata and store it in a kind of feature store, for example. And so you can use ML, MySQL, SQLite, or others kind of database here. And when you finish the process, you have the data and the models in another kind of store. So TFX will be in all the step of this process, help us in libraries and the steps to help us to build it. And in the end, you can use the Apache Beam and other stuff, open source, to build our own process here. So just to give an example for each step, when we start a pipeline, in machine learning pipeline, the first step, you need to get the raw data. So this raw data can be from the CSV file, TF records, and another kind of data. So the first component from TFX is the example gen. For the example gen, it's a component that you can take data from out of kind of research and building one data record and slice this data record in training mode and training data and evaluate data. So once you have just all the data in one specific environment, you start to use another component to evaluate this data. The first one is the statistic gen. With the statistic gen, you can evaluate and have some visualization statistics about this data. For example, the means, the maximum value, the mean value, and so on. So then we'll have another component that the name is schema gen. This schema gen is allow us to see the configuration and the visualization, the schema of your data. So you can see the type of the data, the valency, the domain, and etc. Once that you do you get the data, do the statistics and the schema of the data, we start another component that the name is example validator. With the example validator, you can validate some examples of your data to examine some anomalies of the data and do some reports about our data. So the next step in this process, in the best process of a process of machine learning, you start to transform the data. So you can try, for example, if you have some numeric features, you can transform it in the categorized features and so on. So these components transform allow us to do it in the very simple way. And then once we have the data transformed, you have the step to training the model. So when you start the training the model, as you know, if you do it in the GCP, for example, GCP allows us to use some very strong hardware, for example, TPUs, that allow us to train a model very faster. And once that the model are trained, we start to evaluate this model. So you need to evaluate, and you have another library very, very popular and useful is the TensorBoard. And in TensorBoard, you can see in the real time the distribution, the graphics, and the results of our model in training time. And then visualize all the results, and if the result is okay, you can go for the next step to validate the infrastructure that your model will be released, and then publish this model and use this model to have the inference for your application. And all this stuff, it's open source. You can use all the TFX components with many languages like Python, Java, Go, SQL, and use a lot of open source things like Dataflow, Apache Flink, Apache Spark, and so on. So it's a very flexible and open source tools that you can use to building our customized process end-to-end platform to training and deploy the machine learning models and the applications. So in the end, you have this this pipeline in production that we start here in the train to get the data and pass for all the steps, and have TFX have one library or more than one library to help us in each step. Kubeflow to managing all the pipeline and the other stuff. Like I said here, you can do the orchestration with Kubeflow or Flow, so on. You can store the metadata in MySQL, SQLite, and so on. Processing API with Beam, and running in Spark, Kubeflow, and Dataflow on GCP, and so on. So it's a very flexible platform, and you can build and customize for what you need. And you can use, of course, the GCP, and you have a lot of services building just to use more fast way, but you can build our own platform, customize it, and run it in our infrastructure. So I have some reference here that you can go more deeper in this concept and try some things. You have some code to test, etc. And I think that's it. Thank you very much for having me again. I hope that you enjoyed this talk, and feel free to contact me in the social media. Thank you again.
It feels like I miss an audience with everyone clapping, so I'm representing everyone here. Vinicius, thank you so much for coming here, and also for leaving your DMs, your email open to the community. I really, really appreciate it. And I hope to see you in GDG Cloud again in the future.
Thank you. Thank you very much.
Thank you. So I'll leave you to dinner, I guess. And I'm going to do just some final giveaway now. So thanks again. I'm going to remove your video now. And so we even have some claps from Peter. So basically, I'm using this wheelofnames.com, and what I do is I import Twitter users, and I'm searching for everyone who wrote GTG Cloud. It could have been @ or a hashtag, so I'm just using all the GTG Cloud, and I'm going to remove my own account and the GTG Cloud's account, and I have 3 licenses to give away. I'm just going to give like 1 more minute in case someone else would like to post something now. If not, just 1 person is going to be left out. So 3 people are going to receive it. And yeah, this is a very cool platform. I've been using it for, I don't know, years during the events. There is dark mode. I don't even know the people who created it. I just really love it. Let me see if we have anyone else. No, I think that's it. So let's spin the wheel. First one is, I think that's you, Peter. Isn't that you? Congratulations. So DM me and I'm going to give you a license. Second person, spinning the wheel.
Catarina Gomez is saying, just a second.
Oh, we have a just a second. Someone wrote just a second, sorry. So Yo-Yo got the second one. Just a second. Okay, I'm going to import you to the last one if you have already posted, Catarina. I don't think your post is here yet. I'll give you some more seconds. So, are you done, Catarina? The thing Sav gave me a shout. He's like, Catarina has one more. Well, you have my contact. I'm going to send you the license for JetBrains. Okay, Catarina is ready for JetBrains license. So, yep, I can see you here. I am not going to get one. You already got hers. And Peter already got his. So, final one. Let's see who the lucky winner is. And it was worth the wait. You got it, Catarina. So you can DM me. This is my Twitter or GDG Cloud's account, and I'll very happily give you the license. So that's all we had for today. I'm so thankful you've been here with us for over 2 hours on an evening. Maybe some of you had dinner with us today. So thanks for your time. We're going to try and keep some constants in having at least once a month a general talks event, but we have some more events coming up. Yo-Yo, who was one of the winners here, we are preparing an event for you. There's more news coming soon. And overall, thank you for being part of this community, for being here, for spending your time with us. Your opinion is super important. So whatever you like or don't like about our events, you can openly come and talk to us, and we'll try our best to deliver the best content for you. So good evening, good night to the people in London, and have a good time of the day for people anywhere else where you are. Have a good one, everyone.